Hey everybody, and as written right there on the OneNote, welcome to assignment 4. And for this assignment, we're going to work with binary trees. Now, not binary search trees or AVL trees, just regular ordinary binary trees. So in this program, I have the header file provided. So I made some modifications to the header file if in case you're still having issues as to where to get started. Hopefully this header file gives you an idea. And I will sort of summarize these functions up in a little bit, but I want to just go over the introduction for this. So in this program, you're going to be reading an input through a command line argument and through Linux redirection. You're going to read in characters from a file, and you're going to construct a binary tree using a level order traversal. So if in case you didn't cover that in your class, I will go over just an idea as to how to implement this level order traversal. And after that, then you will use your standard pre-order, post-order, in-order, but it'll be just a tad bit more sophisticated than what you might have encountered in your class. So instead of just C-outing everything, you'll be doing something slightly different, but in reality, not much more difficult than just a plain pre-order, post-order, and in-order. And of course, these two functions here, scramble message and unscramble message, these two are going to be non-member functions of your tree class. You're going to simply, these two functions will be just called in main. And then in each function respectively, you will have to create a local tree object in each of these. And of course, you'll have to call upon some of these functions. So also I provided you the tree.cpp file as well. Again, they're mostly blanked out. Some of the functions here I do provide some code because you have these two, two pre-orders. So here's the public pre-order function. Here's a private pre-order function. So basically this public one, which will be called in the scramble and unscrambled functions, you create a tree object and you call pre-order, you pass in your vector of, well, either vector of integers or vector of characters. So this is templated so it can handle either type. And then this function will call the overloaded preorder. And you have to, of course, write your code here in your preorder function, but it'll be a very standard, simple function to write. Same thing for post order and in order. You just have to call upon the other function, the private one. So it's a wrapper function, basically. You call this in your unscramble and scramble, and this function is going to call the private overloaded one. And this is going to be where the recursion, aka the magic, will happen. Of course, these two functions are going to call the tree objects public member functions, of course. So you're going to have to now work on the insert function, which is provided for you, right? Let's see, where is it provided? There it's insert, there we go. So you're going to have to write this non-recursive function that uses a queue data structure, and I'll give you some ideas as to how to approach a queue data structure. And you will have to call that in these two functions to construct your binary tree. Without that, you can't really do anything else. So insert is rather important. So let's go ahead and just go over how this insert, aka this level order traversal, is going to work. Okay, so suppose you have this vector passed into your message. So the vector sometimes could be a set of characters, so a vector of characters for that type, or it could be integers. So for the scramble function, you're going to pass in a vector of integers to basically be able to implement that scrambling technique. And if you unscramble, you're going to be receiving a vector of characters. So making this function templated makes it easier to reuse the code. So the result right here, what you really want to have, is given this message vector, you want to create this picture. So you want to have 0, you want to have 1, 2, 3, this is not really drawn nicely, 4, 5, 6, 7, 8, and 9. So you want to create this tree. And it's very easy to actually visualize how level order works. So when this insert function is done, you're going to insert in level order. Now, I actually modified a function a little bit on my end where I passed the entire vector in. So I believe in the PDF provided, it has just insert with a single type. So I think this function is called multiple times actually in the in possibly a scramble unscramble function. But just to make it easier, I guess for me, I find it simpler to pass in the entire vector of ints or vector of characters, and this function will loop through this entire vector and construct this tree. But you can see here, it's very easy to see how it correlates. So 0, then 0's children 1, 2. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can see how it's very easy to visualize how this would be turned into that. Now, of course, you can draw it out easily, but now the question is, can we code it? That's always a problem. So let me go ahead and give you some hints. I'm going to type some code over here, but I will also draw at the same time. I won't give away the entire program, but just give you an idea of how to get started, since possibly maybe in your class you didn't cover level order. This will be like your lecture on that. So I'm going to right now just create a root pointer, or actually, sorry, we have our instance variable root defined in our tree class, root mu node. And then of course, root, so maybe I'll create like a variable, like int, let's say I equals 0. And then I'm gonna say root arrow data equals message I. So we're gonna start the very first character. So let me draw this out at the same time to give you an idea what's going on. So we have our root pointer right here, and we're going to allocate a node to it. I'll use this fancy arrow object right here. And then we're going to assign the very first character. Since I is set to 0 initially, message 0 will be just that character, that digit 0 right there. That's going to get stored in this node. So that's not so bad. And then what I'll do is I'm going to just I'm going to go ahead and store the two children for root. So I'm going to say root arrow left equals mu node, and then root arrow right equals mu node. Okay, so when I do that, what's going to happen is we're going to allocate two nodes. This is not going to be drawn to scale perfectly, but I think it's actually pretty good. So root arrow left points to that node, and root arrow right will point to this node right over here. So what we can do right now is I can just say the following. I can just say root arrow left arrow data equals message I++. Now remember, you can separate this, but what I++ will do, or actually, oh no, I should put I++ over here as well, sorry. Because what I++ does is if I is 0 initially, then it will just use the value of 0, and then the plus plus is applied to I afterwards. So I is 0, we're going to look at index 0, store the data, and then I becomes 1. And now I is 1. Index 1 of message, which is the character digit 1, will be assigned to root arrow left arrow data, which we put 1 there. And then I updates to 2. So remember, a plus plus, the postfix operator updates the integer after the statement is done. And same thing, I'm going to say root arrow right arrow data equals message I++. Now, of course, you have to check for balance checking as well here, because if I goes beyond the bounds of message's size, it could mess up, but I'll leave you to worry about that for right now. So then what's going to happen is index 2 has the value 2, and we're going to store that into root arrow right arrow data. So far we have this picture somewhat created, but we're not quite there just yet. Okay, so this part, I believe, is rather straightforward. I don't think anybody will have any problems with this. And also, to be safe, actually, I don't have to worry about that right now. So what I'm going to do, well, actually, I'm going to go ahead and just say, just to be safe, actually. So root arrow left equals null pointer. Although I believe in my header file that I provided, actually, just make sure yes, I actually, in my header file, I actually provide constructors for the struct node. So it's going to set the left and right children to be null automatically. So in fact, ones left and right will be automatically null because of this constructor, and roots right, left, so this node's left and right are going to be set to null automatically because this constructor right here is going to assign null for the left and right nodes. So we don't have to worry about actually setting these here because our constructor does it for us. That's a good that we have that, because otherwise you could make a mistake and accidentally not set these to null. Okay, so now you were probably mentioned that there's a queue data structure of some sort you have to work with. And what I'd recommend doing is creating a queue of pointers. And we'll go over why. And I'm going to call it Q, I guess. It makes sense. Q and Q. That's not ambiguous at all. So this is Q. This is also Q. Two Qs. But I'll refer, maybe I should, I'll call it Q. Why not? It makes it more fun. So right now what I'll do is the following. So let me just draw the Q data structure, the letter Q data structure, I should say, right here. So we can see what, let me see, I think it's Control Shift. I should be able to, okay, fine, whatever. So I'm trying to actually control exactly how far I want this to move, but it's not allowing me to do that. Okay, that's going to be annoying for some reason. Okay, that's fine. So anyway, here's our Q data structure. Will look like this. So consider like a line in a grocery store. We're going to have the following setup, so we can think of it as one giant line. And what we're going to do is I'm going to say Q dot push root arrow left. I'm going to say Q dot push root arrow right. Okay, so we're going to, oops, I should call this root. So essentially we're storing, so Q essentially, remember how Q's work from 202. When you do a push, it puts it to the back of the line, and then pop goes in the front of the line. Now, we're using pointers because it's going to make it a lot easier to implement this structure. Let me actually move this down just a little bit so it won't get in the way of the tree above. So what's going to happen is we're going to push the addresses. So we're not actually going to push 1 and 2, but we're pushing the addresses of 1 and 2 onto this queue. So what I'm going to do right now is I'm going to create another pointer, node star temp, and I'll say temp equals q dot front, I believe is the function. So the front function is going to return the very first node. So it's not going to return the actual node itself, but the address to the node 1. So then temp is going to be assigned actually to this node right there. And then I'm going to q dot pop. The pop function is going to remove this address from my queue. So now that temp points to this node, well, guess what happens next? Do the same exact thing we did a second ago. Except we're going to be using temp, not root anymore. And guess what happens? Temp will assign 2 children, and guess what the values in each node will contain? Well, it's going to contain 3 and 4. Remember, because our I index last left off on 0, 1, 2, 3. So we know the next element in our message will allocate 2 nodes over here, store 3 and 4, or message I++ accordingly. And then we're going to push these 2 nodes. So let me just quickly draw this right here. We're just going to, this is what happens. So we just allocate these 2 nodes, and we store 3, 4. Then we're going to push the addresses of those 2 nodes onto the queue. And then when we go ahead and we assign temp equal to queue front, what's going to happen is now temp is going to be assigned to this node. And the reason is because we pushed the address of that node onto our queue, so temp will magically point to that node in our current tree, and guess what we do there? We allocate two nodes, and since our I-index, we know our last place a message, we would just store those message I++ into temp, arrow left, arrow data, and so forth, and we push those onto the queue. And then we do this process until our queue is empty. Now, if at some point, if our I-index goes beyond the bounds, then we can't allocate a new node and we can't push a new node. So sooner or later, this queue will get empty and we'll be done. And of course, there is a queue.empty function, which is going to be used. It returns true if the queue is empty and false if it's not empty. And we can use this technique to construct this tree. So hopefully this code explanation and picture gave you an idea. So we will come back to this a little bit later on when we go into graph theory, but at least when we go into graph theory, this will actually make sense. It's actually level order is known as a breadth first search for graph theory. So you can maybe look up some help on this. I'll write this here for you. This is actually known as breadth first search. Anyway, so that's going to be it for the insert function. So now I'm going to go ahead and give you some ideas for the pre-order and post-order and in-order functions slightly. And of course, how to scramble and unscramble these messages. Okay, so I'm just going to give you really a very obvious hint for how to do pre-order, post-order, in-order. So the first question is, do you remember pre-order function from class and how easy it was? Remember that? Well, this is not going to be that much more difficult. So let's go ahead and take a look at this. Check this out. Node star R. Do you remember this in the actual function prototype when we covered pre-ordering class? I mean, I'm hoping you remember this. This is nothing, now got a type name there and so forth, but in reality, we're passing in a pointer to a node in our tree. Remember how in class, or maybe depending on what class you had, but remember, most likely in class, you would have covered just couting nodes, right? So, message, this vector, that's going to be your cout, if you will. So what does cout really do? Well, cout keeps writing to the back of the output stream. So think of message, that vector is your output stream. Is there a way to insert to the back of the vector? I think there is. And that vector, that's going to be your cout in a sense. So you have to replace that cout R data with something else, which will write to the message vector. I'm going to stop talking right there because I think I'm giving away too much, but that's what you're doing. Is you're going to write the result to message. That's going to be the pre-order, post-order, in-order result. So when you, and of course we pass it by reference. So when we update this message vector in our pre-order, post-order, in-order functions, when we return back, so we're gonna call these functions in unscramble and scramble messages. So we create an object. We create this tree object, and we call the tree objects pre-order, post-order. So you would do something like this. I mean, you would do something like tree, character, or you can do tree int, t, and do t dot insert, something in here. I mean, I guess you want to create a vector, I'm guessing, for message, but and of course you would just do, then you would have t dot pre-order, and you pass in your message. You want to pass in a vector, not a string, so you have to just convert this into a vector, which would not be that complicated, and that's going to update and process this object. And of course, after you return back, this message vector is going to be the result of the pre-order, post-order, in-order traversals. So essentially, you have to make sure you insert first, which is going to construct your tree. And afterwards, you're going to pre-order, post-order, in-order process this tree. So anyway, let's go ahead and I believe the unscramble message is very obvious. So you're going to be passing in this string. You want to convert it into a vector of characters and then build this by calling this insert function. That I modified it a little bit, but this insert function is going to work. We're going to construct it, and then we're going to either pre, post, or in order it, and then we're going to be converted back to a string afterwards and return that string, which will be our unscrambled message. For scrambled, this will be a little bit trickier, so I'm going to, I guess, give you the idea for how you want to do the scramble message function. So I'm going to pause the video and sort of go over this right now, since I can imagine I'll make some mistakes when I do this. I don't want to have to like remake the entire video, so I'm going to go ahead and pause it, and I will go ahead and talk about how to do the scramble message function. Okay, so this is my third time actually trying to record this. So I always made some small mistake, or I would stumble when I was doing this, and I didn't want to, upload that stumbled video up onto YouTube. So I just kind of cut, deleted that segment, and I would just retry. So my third try. So hopefully a third time is the charm, and I get this to work. So in this scramble function, suppose your string message contains that string right there. Now, for scramble, you're not going to actually pass in a vector of characters. So for unscramble, that's what you would do. But for scramble, you have to pass in a vector of integers. And those integers are going to be the indices of this string. So let's look at the indices. So let's put these right below over here. These are the indices of this string. So you want to create a vector from that contains 0, 1, 2, 3, 4, up to 9. So a vector of integers that contains 0 through 9. So of course from 0 to size -1 of this string message. So that's not really too bad. So once you do that, you're going to pass that vector of integers into the insert function, which is of course going to construct your level, or it's going to construct your binary tree using level order traversal type. So it's going to create the following binary tree right here. Not hard to visualize how this will look. We just go through in level order. There we are. Okay, so here's our binary tree. And now what's going to happen is we're going to, let's say you wanted to scramble this using post order traversal. Well, our post order vectors, so if you look at the post order function right up here, let me go to the code for a second. So right up here, this vector, which I called it message also, but feel free to rename it to a different name. Maybe I'll call it M for right now, so it's not going to cause any confusion. I'll call it M. So this is going to be my message string. Let me put the M vector right here. So we're going to write to M, and we're going to write this in post order form. So if you were to traverse this in post order, you would get 783, 7, so let me make sure I'm correct, 783, 9, 4, 1, 5, 6, 2, 0. That's going to be the post order output. That's going to be stored in my M vector in this post order function. So let me double check once more. I didn't make mistakes on the post order. I may have made a mistake on the actual scrambling part. So let's see, 7, 8, 3, 9, 4, 1, 5, 6. Okay, cool. So our string is correctly, sorry, a vector of integers is correct. So now we want to do is we have to, of course, well, go through this vector M. So I'm going to now, again, I'm going to pause this video to ensure that my third time will be successful. So I'm going to pause right now, and I'm going to go over the separate scrambling parts. It's actually not that complicated, but very simple to mess up. So I'm going to pause once again to make sure that the third time will, in fact, indeed be the charm. Okay, so for this M vector, I just put the indices in here, just while I had the video paused. So we had the indices, and str is going to be a string that we're going to return from this unscramble function. And I set this string size to be the same length as my original string, or even set it to the size of the vector because they're all size 10. So here's how it's going to work. So what we're going to do is you go from left to right in this vector right here. So we have index 7 stored right at the beginning. So what that means is we're going to go to index 7 of our str and store the character 0. So 0 is the index of where t is in our original string. And then we're going to put this into index 7. So t is going to go to index 7, the letter t. And next one is going to be index 1. Index 1 contains letter E. We're going to put this in index 8. So E is going to go right there. And then afterwards, index 2, which has the value, which is S, will go to index 3. And then index 3 contains lowercase t. We're going to put this to index 9. And then, let's just finish this off, I suppose. So index 4, this is actually not going to cause any difference. Index 4 has a space. We put in index 4, so I'll use the underline to represent a space. We're not putting underscores here, but underline will help us denote that means space. And then index 5 has a digit, it has index 5 here, character 1. We're going to put that into index 1. So character 1 will go right over there. Index 6 has a blank. We're going to put that index 5. So we have another blank right there. And then afterwards, index 7 has the digit 2. And we're going to put this index 6. So 2 goes right there. And then index 8, which has a blank space, we put that to index 2. And then at the very end, index 9, which is the digit or character 3, we're going to put index 0. So 3 goes right there. And I actually did it there. That does actually match. So the one of your files, which is going to be the post1.txt, which is going to be the scrambled text using post order, it does actually match that. So that's how you want to take the result of that m vector and be able to store it into your string variable. So for scramble, or sorry, for unscramble, you don't have to worry about it, but for scramble, you have to do this extra bit of work. So there we go. So now let's go ahead and go over how we can just simply run this code, just so you have an idea of how it's going to work. And I'm going to use the same exact input and outputs on CodeGrade as well. Let's go ahead and get into that next. Okay, so for this program, I provide you with all the inputs right here. So it's all in one directory, so it's easy to, I guess, decipher all this. So unscrambled 01txt is the original text unscrambled. Here's unscrambled 4, unscrambled 8 is the original text as provided. I'm only going to pick a few of these. I'm going to choose all of them, so it'll take way too long to create the auto test. So I just chose a few, but I don't think there's any edge cases in this program, so really just have a few different tests just because why not. And then this pre1.txt is really just, if I take this unscrambled text and I feed this into my pre-order function scrambler, that's the result we're supposed to get. And then if I pass this unscrambled txt into my post-order scrambler, we should get this output, which actually does match the output that I provided for you in the last segment of this video. So it does match actually, and same thing for in order. So those are 3 different ways to scramble it. And of course, for unscramble 04, pre4 is going to be just the scrambled version of that text. So I put it all into one directory here for you, so it's easy to navigate all that. Okay, and we're going to use the same exact inputs on CodeGrade as well. So let's go ahead and now just sort of run this. So let me go ahead and just show you the terminal right here. I guess I'll just sort of redo this. I made a mistake actually earlier, so I'll just have to redo this right here. So to compile this, we just do g++ main.cpp, then tree.cpp. There we are. So let's go ahead and just to test out, I want to scramble this text using pre-order traversal type. So to do this, we will do /a.out, and I'm going to put in scramble. So we're going to want to scramble this text using the pre-order traversal type. And now we're going to feed in our input using a Linux redirection. So we're going to use this arrow symbol like that, followed by unscrambled one.txt. So it cut off to the next line, but it's all one line right there. So we're going to feed this input into our program. And these are two command line arguments. So we want to scramble using pre. Here's my file. Let's go ahead and run this. And that's the output it produced. Let's hope that it was the same output like right there. And it is. So it did work. So it's the same exact output. Now again, if I wanted to, let's say I wanted to unscramble this really large one, well, what I can just do is just again, just put a few lines here, /a.out. Let's scramble this one. I'll use post order scramble this time. And I'm going to use unscramble04.txt. And I put it onto one big line. No, sorry, it's actually 04. I want to do 08. My mistake. Sorry. I was going to say, that was way too small. And that almost gave me a heart attack. Like, wait, it's supposed to work. It worked. And I already have code grade set up, and now it's not working suddenly. What the heck just happened? Okay. That looks a little better. So let's go ahead and go to the post 08. And, there's the same exact string like right there. So it looks about the same. And now, of course, you want to unscramble. Well, what we can do is just do /a.out unscramble. And I guess I'll use pre actually. So let's look at the pre text. I think pre 08 is going to be our text that we scrambled earlier. So unscramble pre. Then I'll just do pre 4.txt. And again, I chose 4, not 8. I don't know why. Maybe I'm getting tired. Okay, let's try this again. Let's try 8. And we can see there that it did correctly unscramble it. So pretty much on code grade, it's going to just simply test all of these out. And that's how you would run these. So of course, you just put it into command. So whenever you want to unscramble, using pre, post, in, use the pre, post, or in 148 to unscramble. If you want to scramble, you do /a.out scramble, pre, post, or in, and then you put in this redirection, and then you put in the unscrambled text because you want to scramble the unscrambled in that case. So anyway, you also can check code grade for the actual compiler commands as well. It's all right there. So hopefully this video did give you at least a little insight for the assignments. I guess happy coding, and till next time.